afternoon. I'm here with Ian Taylor, who will be presenting on blockchain security in the defense supply chain community. Ian is with Chain, and would you like to sit or stand?
I'll stand.
Okay, then I'll leave that there. But you're taller than I am.
Hello. It's like, hey, we may as well just get to know each other, I think. It's like 10 people or something. Okay, so I'm Ian Taylor. My background, a bit by myself, I was born in a place called Wrexham. I don't know if anybody heard of that. Ryan Reynolds bought their football club recently, so made it famous. But I spent many years in research. So I was a professor in the University of Cardiff University in the UK, University of Notre Dame, which is where Simba started. So as a professor in Notre Dame, I put in a SIBA award with DARPA, actually, relevant to the last session, with the local company Atamco, and it was about secure messaging using blockchains back in 2016, I believe, and that was selected for funding. I called the proposal Secure Messaging Using a Blockchain Architecture Simba, and that's where the name came from. So it's a bit of background, and we lost the slides. Okay. How does so you go up here or down? Yeah. Okay. Yeah, these are kind of messed up. There's a PowerPoint. Okay. Anyway, so cryptocurrency, if you look at this 10 by 10 set of boxes here, cryptocurrency is one use case, right? Smart contracts enable that and many other things. Simba really is more about those other 99 use cases, or some of them. We're more about tokenizing data than value, and that's kind of the basis for what we do. This is skip 10 slides or something. Okay, maybe we forget the slides and I just talk. Yeah, this doesn't work, guys.
Can you just cue it when you want to change it? Because somehow, because it's...
Yeah, there's a PowerPoint there as well.
It's coming up as Google slide.
Oh, I don't know. Okay, so next slide. See if we can do it that way. Okay, all right, thanks. Chain. So we've been doing a lot of work in the government side of things. We've basically had contracts with most of the divisions now. Air Force is by far the biggest customer. According to Bloomberg, we're the largest supplier of blockchain to the government, to the US government, in a survey they did from 18 to 24. In terms of selling to the government, as Gerard was touching on, it's really kind of difficult to sell blockchain, I think. Blockchain solutions, people immediately get lost into the Bitcoin world and they don't come out again. So we tend to kind of describe the other technologies which I'll go through that we support as well. Blockchain is very much part of our stack, but we talk about digital signatures, verifiability, things like that. And you know, if blockchain comes up, we go with this narrative. It's like an operating system. You don't need to know how it works. It just works. It just provides that trust layer. So next slide, please. And then this one. So next slide. Okay, so these are some of the use case kind of in the general area of tokenization. I just learned about another one, cattle over lunch. So this is by means the only things going on. Real estate, there's a lot of this. I guess there's been many talks about these kind of things. Luxury goods, authentication. Vehicle titles, 42 million. Apparently are on the chain, on Avalanche blockchain for California right now. And then there's also, finance, asset tokenization. So we're kind of in these four at the bottom. So, and I go through these use cases, one of which is in the concept of a digital product passport. So you basically take your phone out, you scan a QR code. That QR code goes to a page that's very specific to that product with that serial number. So we're providing traceability for batteries basically right now throughout their life cycle. So you can keep on, you can have updates like of the state of health of the battery and things like that. We've also used this in the past to do audit mechanisms for budgets. So again, with the Air Force, we applied this to contracts and subcontracts and flows of money between them and tokenized all of that. That was successful, and that went in Gerard's book, or whatever that was called, a book that he released earlier this year. The military asset tracking is another one. We were involved in a live use case which sent 600 tons, 10 packages of information, of assets to Ukraine. That was Simba on the back end of that. And then the Air Force supply chain. So StratFi project, that's kind of the core one. That is the largest contract we've had to part, and that's really bringing in data from folks like Boeing and Spirit Aerosystems and so forth. So next slide. Okay, you can skip this one. Well, this is just numbers that I pulled out of Claude, I think, for the different sectors: supply chain, authentication, 8.2 billion digital credentials, event ticketing, loyalty and rewards. This is, okay, gaming and metaverse and so forth. So let's go to the next slide. There's feedback from this mic. Is it because the volume is too high? No. If you go to the next slide. Next slide, please. Okay, so this is our stack. We have, at the bottom, everything is layered on a blockchain. We have an interface which we built over many years called Simba Build. It's basically an abstraction layer that takes away the particular blockchain and provides a very simple interface to that. We use REST APIs to get data in and out of that and so forth. We've supported about 14 different blockchains over the years, including non-EVM based ones like Hyperledger Fabric, Stellar, things like that. So it's quite generic. Is everybody hearing this feedback? Or is it just me? Maybe it's, I don't know. Okay, so, and then on top of that, we've got Simba Ensure. Simba Ensure basically provides a verifiability layer and identity. We use decentralized identities and verifiable credentials, but we use them for everything. So every piece of data that comes into our system has an ID. Every person that interacts with our system has an ID, and every software system has an ID. And we use those in different ways to secure the transfer of data or secure data itself. And then the last piece, we use graph databases, knowledge graphs, to tie everything back together. So everything that comes into Simba gets secured, gets permissioned using those two bottom layers, and then everything gets wired back together in a graph. But the graph, once the data goes in the graph, we then take that insert on the graph and we tie that back to the blockchain too. So when you're looking at the graph, you're looking at fully verifiable blockchain-based data that can't be changed or tamper evident if it does. Next slide. Okay, so this is the build piece. It's got all of these different, I think there's 12 different components in this that kind of collectively make it simple to interact with the blockchain. So we have different blockchains at the center. We've got transaction validation. So if somebody tries to send something to the blockchain that we know it's not going to work, we send that back rather than having it kind of transact. We have virtual APIs, so every smart contract is represented as a REST interface. So you can interact with that rather than interacting with the blockchain directly. We then have search and access APIs, so it's very easy to search all of the data. We do support searching through the REST APIs if you know what you're looking for specifically in terms of the data. But we also expose that as a connected data set in a graph as well, so you can query across transactions if you like. And then we also support things like subscriptions and off-chain data automatically. So if you want to secure data files, you can send literally 10 files to our system. We'll create an NFT. We'll put a fingerprint of those collective files on-chain and secure those in whatever file system you choose. The key thing, though, to make it simple to integrate with other systems is the auth model. So we support essentially any system integration with Simba. So what happens if you have an ID in a system? So you have an existing system with existing users. They already have identities. We take those identities and we auto-generate a wallet for those users automatically. That's deterministic to that ID. So putting blockchain on the back end of an existing application is simple. It's just basically registering that user the first time they have the wallet. Every piece of data or everything that user does from there on in is tracked and put onto the blockchain. So next slide. So just to touch on decentralized identities and verifiable credentials, a DID is essentially an opaque identifier. And along with that, you have a public and private key. Now, DIDs, there's many identifiers for identities out there. DIDs don't exist by themselves. They do have some function in terms of the public-private key to verify who you are, but they're really designed to use with verifiable credentials. So if you can go to the next slide, please. So this is the way the system works, essentially. So a DID can issue what is called a credential. A credential is a digitally signed document that is issued by an authority, so a person with a DID, and they digitally sign the document using their private key, and they issue it to another DID. And that gives the other DID a permission to do something or, attest something about that individual or software system. So you can imagine we've used this in many ways. So one of the ways we use this is to permission access to data. So imagine those same 10 files coming through Simba. We store those in a file system. We then have an NFT that represents those. That NFT becomes the verifier in the system. And the verifier checks a couple of things, right? So imagine Bowen wanted to share data with me. Bowen would send us data, store their data. We'd have this gatekeeper. They would then digitally sign a document, a credential, and issue it to me, my identity. I would then present that to the system. And this verifier is on-chain. So being on-chain, it can't be tampered with, right? It can't be changed. So it's kind of like an unhackable permissioning mechanism. So the verifier checks two things. It checks if the signature on the credential is authentic. So it checks on an on-chain registry whether that is Boeing's signature to check they have permission to issue this. And it also checks I am who I say I am. And to do that, the way that happens is you send me a number encrypted with my public key, and then I would decrypt that with my private key and send the same number back, proving that my private key is under my ownership, and therefore I am that identity. We do a slightly different approach because it's on-chain. It's a one-way authentication, but those two things happen. We also have, that would give access to the file, but also in that credential, we use attributes which kind of confer the scope, what you have access to specifically. It's an attribute-based, permissioning. So, okay, so that is the kind of permissioning piece. Okay, next slide. I think we can skip this. This is just an example of that happening, and I think I went through this, so I don't think we need to go through this again. So next slide. Okay, then Simba Insights. So this is a graph of last week. I asked my engineers to generate what a graph looks like in our system. And really, we use graphs for many things. So one of the things we're doing for the Air Force is provenance. So the graph can store data. We use it to store data. We tie that back to the chain so it's fully verifiable. But we also incorporate the provenance standards. So it's called PROV. It's a W3 standard. And that defines entities and interactions between entities. So when Bowen sends us data, for example, we're not only converting the data into a graph so we can query it, we'll also have a record of what happened. So we'll have a connection, we'll have an asset, which is the data, we'll have an entity, which is Boeing, and we have a relationship about that happening. So everything that happens to that data is tracked. So for example, if we sent that Boeing data now to our partner who does predictive analytics and AI and stuff like that, if they take that data then and they blow up one of the nodes, so say they have 40 sub-tier suppliers, and they take one of those sub-tier suppliers and they do a risk analysis on that and blow up the graph in that perspective. That data comes back to us, and we add that to the provenance graph. So every change, basically if you look at a piece of data, once it's gone through Simba, you can understand not only where that data comes from, and the data is digitally signed using the DID anyway, so you have proof who provided that data. You also have every single change that happened to that data, and then you can look at that history and see if you're still satisfied with that data before you use it. We're doing a project now with the Air Force again in AI, using the same scheme and same graph-based approach and DIDs and VCs to apply to agents. So you can understand which agents can actually participate in a specific task, and you can secure the transmission between the agents and so forth. But this is kind of how we pull everything together. So the graph, if you like, one of the customers, I think one of the use cases later, I'll mention that, but he looked at this graph and we have this picture about his use case, and he said, oh, wow, that's what a blockchain looks like. And in a sense, that's true, because every node here relates to data which is secured using the blockchain. Okay, next slide. Okay, so this is kind of what it looks like end to end. You have data coming from various different systems, suppliers in that case, in the battery use case, is for some companies it's 30 different systems. It comes into Simba, we take that data, we secure the data, we permission the data so that different stakeholders can see different versions of that data, so we can apply that for users also. And then we convert all of that data into a knowledge graph, so the customer can ask questions of that. We don't typically use the knowledge graph directly as a visual tool. We more create a dashboard specific to that particular application, but it makes it super easy because everything is fully connected in a graph database. And just to touch on the graph database piece, unlike a relational database, which basically is set of tables, and then if you want to ask questions across those tables, you have to join those tables, and you have to do it in a specific way to get the specific data you want to extract. In a knowledge graph, it's very simple. It's a piece of data and another piece of data and a line between them, which is the edge, and that line has a meaning, so it has a relationship. And you start adding to that graph, and you can go to trillions of nodes, but the key point is one simple query can query the entire graph, ask a question of the entire data. So you imagine for supply chain, we have maybe 3 different tiers of the supply chain mapped out in this graph that they can ask any question of. And that comes, what you end up with is a way, connected intelligence we call it, but it's a way of being able to query the data and also fully verifiable data when you're using it in applications. I've got some demos here, but I don't think we're going to be able to play those, so go to the next slide. So this is the product walkthrough. Actually, this is a description of the product, so if you go to the next slide. Go to the next slide. I just want to talk about the overview. So that's kind of the set of tools we use and the flow. What we focused on over the last year is really building a product on top of that is repeatable and easy for customers to use. And essentially, we're calling that Simba Trace. This is just recent. But what it does, it enables you to track and trace anything. So imagine a battery, or imagine your own product. You can take the parameters surrounding that product. You can build a schema. You can do that using Claude or whatever, pretty easily. And then you can just plug that into our system, and 10 minutes later, you've got traceability. You've got that product. Yeah, go ahead.
I just had a question. It sounds like the product can help depending on balance.
Yeah, that's what one of the use cases, yeah. Correct.
They haven't been able to do yet.
They've never done, right?
Right. Sounds like this could probably, I was thinking this could be a help.
Yeah, we've had some conversations around that. You know, the idea of audit trails for everything that goes on. There's a reluctance to kind of do that. We've found it hard to kind of break through those barriers. But yeah, absolutely. That's what we did in Daibat, is exactly that. And it would work. Yeah, so this platform enables you to basically track anything. So the way it works is that the platform enables you to, for example, you can drop in 30,000 serial numbers, and it will literally create 30,000 web pages. And the web page, if you scan it, it comes up with the details of the product. And not only the details of the product, but you can transact to the product across its life cycle according to any parameter in that schema. So to give a kind of a use case, like batteries in data centers, those batteries that they're using nowadays to flatten the load, because when AI is learning, the load is kind of 100%. I was told by a guy that is building these data centers nowadays, he said that OpenAI uses the same electricity as the city of Seattle during training phase. But after that is over and it goes to usage, it drops like massively. So how do you go from Seattle to kind of very low usage? They're using batteries, right? So they're using batteries as a way of flattening out that curve. These are kind of lithium-ion batteries, but they're designed for, quick charging, quick consumption, that kind of thing. So in that case, it costs about $300,000 to $400,000 to fit these batteries into a data center. They last about 3 years because of the use pattern, and they need to be changed. So using our system, for example, we could take weekly or monthly measurements of each of the batteries to see how much charge, what's their maximum charge, and they can watch that degradation go down and plan for that CapEx cost. So that's the kind of, and we can do that for every single battery. Now, of course, I said we create 30,000 web pages. We don't. What's happening when you scan that QR code and look at that data from that particular battery is we're going in, it results in a query with that ID, unique for that URL. That goes into our graph database. There's a query, gets all the information for that specific battery and pulls it into the UI. So there's one user interface, not 30,000, and it's just populated with the different information. So if you go to the next slide. So this is kind of the concept. You can define a schema, plug it in, and really start tracking a new thing immediately. That's our goal moving forward. We are going to a turnkey sort of sign up for freemium model shortly in a couple of months, but this is where we are right now. We can plug that in, we can support any use case. If we go to the next slide. This is pretty much what I described before in that context, so if we go to the next slide. Okay, so this is sort of, what happens to the data in this, product version. It's the same kind of flow. You have a data source. Every data source that comes in for one of these, track and trace for a product is digitally signed. So you know where the data comes from. It's linked to a mutable trail of records using the blockchain, so those are tied into the blockchain. And then everything is wrapped in a verifiable credential, so the web page you're looking at has been certified to be true and has been digitally signed to be so. Now you can go and look at the details of that and click a button and see the long list of things that have changed or been modified for those records. But that seal is a digital signature saying we've checked all of that, and that is what it is. And that is provided to the end user. So the end user just is looking at a web page, but if they want to know the verifiability of that data, they can. So next page. Yeah, from graph to glass, this is the website. I think I have a QR code. We can try that in a minute. But this just takes all of that data and that is in the QR code or however way you access that information, and you can see all of that information. So next slide. I think there's a walkthrough. Yeah. So go through to 2 slides. Next slide and next slide. Okay, so this is what the UI looks like. This demo is for the EU battery standard. This is one use case of many, but the EU have a regulation now. It's coming in February 27 next year, and it requires everybody to have a QR code on every battery that provides a set of 100 parameters that they are enforcing. If you don't have this QR code on your battery by February 27, you can't sell to the EU. That's what they're trying to do. So anyway, we for this use case, we chose EUBR. If you go to the next slide, we've provided an AI integration to make it easy to kind of get up to speed with standards like this. So here I'm just specifying what the product name is. We use that, we feed that into the AI and what the company name is and where it was made. And then the data files, you click on that and you can, a lot of cases, especially in the battery world, you have a product specification, right? You have a manual online PDF that you can download. Interestingly, we worked with the largest manufacturer of industrial batteries in the world, and their data for these 100 parameters was scattered across 30 different systems. It was a nightmare. But they did have a product specification for every product they had. So we built a mechanism that uses AI under the hood, LLM specifically, to translate from what's on that page to the set of attributes that you want to populate. So if you go to the next slide, this is an example of a PowerSafe Enesys battery. It has different batteries here, different models with the different specifications, but up above you probably can't see that very well. I can't anyway. It has all of the details of the specifications of the physical attributes for the battery in them. So once you enter that into the system, if you go to the next slide, what you get out is basically it's about 100% of the static parameters, which is about 62% of the battery passport itself. So it helps them get going pretty quickly. So that's the starting point. You can go in after that and edit those parameters if you've got anything wrong. So it's kind of an assisted approach. And that produces something like this. So this is the web page for the batteries you'll get to. And if you go to the next slide, this shows how you can then create instances. So once you have the product, you can then create instances for that product, so the manufactured batteries in this case. So you go through, you can paste in, I think I did 100 serial numbers here, and it created those in a second or two, came up with a list of pages, and then all of these passports were created. So if we go to the next slide. Next slide, please. Oh, here. So if you want to see if this works, if you take your phone and point to that QR code there. Can't do it. You probably can do it better. You should get a web page which is specific to that battery. Did you? Yeah, okay, great. Phew. Okay, so that's kind of how the system works. So the idea is a customer, an end customer, or anybody in the value chain that you want to expose this to, you could do it via QR codes, you could do it via RFIDs, whatever mechanism. We can individually add data to every instance of a product that, and that can scale to millions of products. So that's kind of what we're doing now. Next slide. Yeah, this is just showing on the back end, everything in Simba is a microservice. We've got 24 different microservices implemented at this point, I think. But, this, This Simba Trace is also a service, and as a service, everything we do on the front end is also accessible by APIs on the back end. So if you imagine integrating this into, a manufacturing setting, you can set up your parameters, you could set up, your number of instances, you can grab the next 1,000 serial numbers, you can send it to Simba using an API, create those instances pre-packaged, download the QR codes for those, because we generate the QR codes, and have them go into your printer machine and put them on the thing. So it's very easy to integrate. This is showing more of the life cycle, so I'm updating a battery parameter using this. And you can't see it, but basically that's taking a parameter, changing the battery level to from 85 to whatever, 82 or something, and click and execute. That adds that event to the life cycle of that product. So it's adding basically a connection to the graph and the fact that happened. And then that automatically updates the web page. So now you see the new battery capacity. And you can also click a button on the UI and see everything that ever happened to that battery. So a full kind of record of everything that's happened as well. So next slide. So for like a quarter of an hour later. Next slide. Let's skip some of these. Okay, some use cases. So we've been, this is an example of how you do track and trace the hard way. This is the first one we did, and we did it specific for Tox. And Tox is it's like a Denny's in Mexico. And they've got business all over they've got 230 locations, I believe. We focused on a pilot which turned into production back in 2020, maybe 19. We had the first initial meetings. But this use case was very interesting because what Tox wanted to do, they asked their customers, if we put sustainability on a pack of coffee, who would believe it? And they asked their customers that question. 82% of those people said they wouldn't believe it. So what they needed to do was to prove that sustainable practice was going on. That's where the blockchain came in vital for what they were trying to do. If you go to the next slide. They actually, sorry about the colors here, they actually 6x'd the revenue to those farmers by doing a couple of things. They took out the middlemen from the supply chain and set up their own cooperative to bring in the coffee and coordinate it with the deshellers and whatnot. And they also used the blockchain to not only track what, the verifiability of everything that went on with those bags of coffee. They also created, when we visited these farms, the farmers were saying, well, these beans are, much higher quality than these beans. And it was to do with the size and the color. So we asked them, would you be able to, separate those? And they said, sure, we could do that. So that resulted in a, great cup of coffee and a really great cup of coffee coming out of these farms, which they could charge more for the really great coffee. So they had a couple of things going on there. But it was great because we saw reverse migration happening back to those farms because they had money now. Go ahead.
Don't the farmers actually recoup more profit from their supply into the system? Because
Yeah.
I think before this, weren't they subject to lots of brokers and, it wasn't being tracked. So I would think this would assist them with profit making as well, because you can track it right back. And with traceability, that should make it much more valuable.
Yeah. That traceability, there's QR codes in the restaurants, and people can know exactly where that comes from. But they also literally 6x'd their revenue. They went from, I don't know what it was before. It was something like, I don't remember the details, but because they were going through a regular supply chain, every point of the supply chain was charging a piece of that. So they cut all of that out, and that's how they got much more revenue. So they were actually paid a fair price as opposed to being manipulated like they were before. So the way this app worked, we built an app for them. The bag of coffee comes in from one of the 25 farms that they track. It comes into the cooperative. They take the bag of coffee, they weigh the bag of coffee, and these are coffee beans, the green beans, and then they take the humidity of the coffee and other parameters. They record that, they put it into our system, and then we generate a QR code. That QR code goes on the bag of coffee. They then send that that bag of coffee to the desheller. The desheller, when it comes back from the desheller, when it comes back from the desheller, they weigh it again and they take the humidity again. So if you think about that coupling, what that does, it binds physical parameters for the humidity and the weight with the QR code. So it's not like, you're just providing traceability. You are providing an anti-counterfeit measure, because somebody can copy the QR code and stick it on a counterfeit bag of coffee, but they can't replicate the weight and the humidity of that coffee. That would be flagged in the system immediately as counterfeit. So this is an anti-counterfeit measure as well. Interestingly, Kona Coffee sells 8 times more coffee to the US that it makes every year. Interesting fact. You've got 1 in 8 chance of getting an authentic Kona coffee. That's how much fraud is going on. And they sued supermarkets, grocery stores and stuff for that. Next slide, please. Next slide. Okay, so I talked a bit about this. This is another way we use the DIDs is with bringing data in from Boeing. We meet Boeing every week. We've been working with them for several years now. They wanted a zero trust mechanism where not only, they want to use the system we developed enables them to have self-sovereignty over their data, so they have to give a credential for access. So that's kind of one piece of it. But they also wanted a way that it was impossible for somebody to interfere with the data en route or change the data. So we had to go through their fit for use process. We passed that, and we're bringing in data every week now from Boeing into the Air Force. Now, the way that works is we use, Boeing has an identity, a DID, and we have a DID on the software side. When they package the data up to send it, they encrypt the data with a public key of the software agent, and they digitally sign that whole payload. So when we receive it on our software agent side, we check the signature. If the signature isn't from Boeing, we just throw the data away. And then we decrypt the data. And if it comes, if it's decrypted correctly, then we know that it had to come from Boeing and it was only received by us. So nobody can go in the middle of that and do a man-in-the-middle attack. So that satisfied there. And we call that verifiable data receipt. It's just an extension of the DIDs and other standards that we built on to make that happen. So next slide. Oh, next slide. These are just in-transit visibility. So this is a use case we did with the Army. I presented this with Matt Goyette in the Capitol in the GBA event 4 months ago, I guess now, which is cool. He said in front of, there was like 300 people in that event, and Matt Goyette, with his full Army uniform, got up and said, when it came to blockchain, I talked to Ian, because Simba is the gold standard for blockchain in the DOW. I was like, yes. But he said that in front of the whole audience. That was nice. But this is the use case. This was a live use case. It's public information that we sent 10 munitions to Ukraine. In terms of sending stuff to Ukraine, at the time, of the $1.7 billion worth of assets they sent to Ukraine, $1 billion was still unaccounted for. So it was a $1 billion problem. And we solved that problem through this use case. All 10 assets made it there. Nothing got lost. And also, we had full traceability. See these traces? These not the actual assets. I wouldn't be able to do that, but they are representative of what we were doing. So we know exactly the location and the route that those assets took to get to Ukraine. When they get to the border, we take those devices off. So the devices are basically, they have a cable. You stick it in one side of the lock and you stick it in the other, and you can wrap it around the asset, basically. when it got to the border, they take those off. When they take off those cables, it sends an event to our system, and it says basically, there's a breach. So we know exactly when those were taken off. The protocol for this use case is that all the assets have to lose that visibility when they arrive at the border, because once they go into Ukraine, you don't want to know where they're using them. So that's one use case, and then if you go to the next slide, I'll wrap up in a minute. This is the graph that I mentioned earlier. So this is the customer said this is what a blockchain looks like. This is a use case we did for DLA. They had issues synchronizing their ERP systems when they sent a shipment from one site to another. The ERP systems weren't connected. So what happened was when the shipment went out, they basically emailed the receiving site and said it's on its way. And when they received it, they emailed back, and that's how they were coordinating this stuff. That was prone to error. So what we did is we took the CBLs, the commercial bill of ladings, and we applied some other stuff that we'd written for the Air Force to that in the form of OCR. So we took those were paper documents, non-readable PDFs, we scanned those, we converted those to data, and then we built this blockchain kind of version of their interface. Deloitte was involved in the front end of this, and so Deloitte built this UI, which told them how many shipments were in progress, how many arrived, how many had errors, and so forth. But they were just querying our back-end data. If you look at the graph here, the CBLs are the yellow nodes here, and the CBLs are the commercial bill of lading, which describe what's going on. As part of that, there's a manifest, and then the manifest nodes, which are the blue nodes, are connected to the pink nodes, and the pink nodes are all of the manifest items in that shipment. So we're tracking all of that, and this is what they wanted to see, but using an approach like this and having everything connected in a data set, they could start asking different questions, like what was the item most shipped from one facility to another? Was it shipped from other facilities to that facility also? And they could start optimizing their network in what's the redundancy going on that, in the way they're doing their shipments. If you go to the next slide, I think this coming to, yes, thank you. So any questions? And yeah, we've got 5 minutes for questions.
Those latest examples, then, it seems to me that's very applicable to supply chains on a more broad base, right? That a lot of
Yeah.
that work leads to is then, if you have a documentation package that can go with that, then not only do you have the information about the shipment, if you have documents associated with each piece or each identifiable shipment, manifest item, then you can associate the documents, and that should also be able to then be put on the blockchain as
Yeah.
a record of each individual piece within the shipment,
Right.
where they're going, what carrier they're using, et cetera. Is that implication of something, or is that an implication of what you're doing, or is that just a possibility?
I mean, we didn't store the physical scans of the documents. We could have, but we didn't. We just took the data and created the graph of data, basically, for that use case. But we could have done that. But yeah, I mean, this came from a supply chain background, so a lot of the use cases we've shown is to do with blockchain. But really, the way it works, it can track anything. It could even be used to track data and changes for data, like I described. It could be used in all sorts of different applications. Right now, we're just focusing on tracking of products, because that's where our front end is set up to automate. But yeah, the back end could do, anything that's digitized, it can track. All right. Any other questions? Okay. I'll hand it back to... She's gone. Okay. So...